folks, computer time. And I'm working on the Cobra 2000, and I figured that I would, give an update. So I'm looking at the power supply of the Cobra 2000, which is a little odd, but otherwise just fine. And I'll explain. Okay, we have three points of reference here. We have chassis ground. We've got a common tie point, and we have a ground. See here, ground, chassis, common tie point. Signal and voltage, so on and so forth. Anyway, so if you notice a power switch, we're switching the negative of the power supply. This goes to the counter and clock module. The radio is here. So the radio is always energized with respect to the common tie point. So when you turn it on, current flows through the switch and into your, and so on and so forth. You get the idea. So this power supply, which is in the clock counter, is always running because this is always energized. So when the radio is off, this is constantly running. Now, this common tie point that you see here, this J0409 pin 2, we'll find that one, okay? And we will find that here, okay? Now, well, not that pin exactly, but here's our common tie point. If you notice, we got an SCR here. When the alarm goes off, it turns this on. And if you see this, when the alarm is in radio mode, as in turn on the radio, current flows through the switch and through the mislabeled signal path, which is actually, this is a voltage path through the SCR, and we move on. And see, it really should be this, and it should be flipped the other way around, but at least here. But that's neither here nor there. So that's what the radio does to be turned on. Okay, so again, here's J409 pin 2, J409 pin 3, and pin 1 is what is used to turn on and off the radio. So you can turn on the radio via the alarm clock going off and program to turn on the radio, which is just simply a switch, or by pushing the power button. So that's basically how it is. Now, how does the counter and clock module know to be in clock mode when the radio is not running? Well, that's an interesting one, and I suspect, and somebody will have to correct me if I'm wrong, there's no way for this module, okay, and this runs off of a TMS 1000. Here it is right here. These things were obsolete when I was in university, okay? These things were old then, and that was in the early mid 90s. These were old, okay? So they're really old now. In fact, I believe well, this one's masked. I mean, you look in the module, it's obviously masked. There's no problem. There's no window, no UV erasable window on it. It's masked. So the program is running on this. It's embedded in it, and that's it. You blow this up, you'll have to replace it with another one out of one of these modules. You're not going to get this part otherwise. But I can't say that I've ever really heard of a TMS 1000 going bad, unless you did something horrible to it. It's a remarkably robust device. Anyway, I think it's PMOS, actually. So yeah, it's old. You get the idea. Now we have this other logic going on here. These transistors, I don't know what these things are doing really. Okay, this one has me stumped. I don't know what the purpose of these. These are something that I gotta put into LT Spice or something to see what this is doing, because I can't figure it out. And then we got this again signal path coming from the common tie point, negative rail. Yeah, I mean, this is a PNP, so we're gonna, I guess be turned on by this somehow. I don't know how it works. I really don't. I just don't know how this works. Um, but anyway, I just don't know how this works. Um, well, that's not true. Now that I think about it, um, and this is one of the benefits of, I guess, me not editing things because I don't know how to edit video or anything like that. I just record this crap and upload it all in one shot. The radio when it's off, okay, the potential on the or here at this point, the potential on the radio is going to be that close of the power supply. It's going to be at 13.5 volts. So when the radio is on, this is going to be not at 13 volts, but it's going to be at, uh, very low. 0.818 is actually a reasonable value when the radio is on. Um, Now with this 10K here and this, yeah. So if the radio is off, this is going to actually turn this is going to turn this on. That actually makes sense. If the radio's on, this is going to turn this transistor on. So, I guess now I'm sort of getting what they're doing with this. This turns this on, this syncs this thing down, turns this one on. So, yeah, this is changing the configuration depending on the power state of the radio. It's very elaborate, but I guess they have to do it considering how they're switching the radio. It didn't register to me before because we got this, and we got ground, and we've got the negative. It takes a little bit to get the mind wrapped around it, but I guess I see what's going on there now. Okay, that makes a little bit of sense. So that's got to be what tells this counter module that the radio is on or off. Huh, okay. And I'm actually going to be using this for the same purpose, come to think about it. But this is going to change the dynamics of how I've got this um, worked out. See, how I've got this all done is um, ignoring this connection, because initially I was going to ignore this pin 10 on J410, just not connect it. In fact, I was just going to pull it to, leave it floating, and just leave it be. So this didn't do anything anymore. Because remember, this is implemented on the counter and time board, but I didn't want this. I didn't want this transistor triggering and doing anything with these switches. So that's why I left this floating. But I actually want to use it to detect whether or not the radio's on. So my thought was, without really looking at this very hard, okay, and this is what I've got. Okay, this is the power on detection. We got a 22K and we got a 6.7 or 3.6 volt rather zener. This is a little, if you will, a little crude power supply. It supplies a very low amount of current, but this isn't the intention of this. This is to pull this pin high when the radio is off. This has got a high on it, and therefore I can poll this or attach an interrupt to PE2 and say, okay, if this is high, then the microcontroller needs to sleep, and to trigger an interrupt on the negative going ramp. So when this thing goes, when this gets pulled low, because when the voltage disappears in this, essentially, because when the radio is turned on, this is going to go. There's no voltage here anymore. But since this is at 13, going to be at 13 volts, I need to drop this down to something reasonable the microcontroller can handle. So 3.6 really probably should be a 3.3, but you get the idea. This is just to pull this high, and when the radio is off. When it's on, no power. Um, And that's just over here on pin 10. Keep in mind, pin 2 is not actually physically there, and they count it 1, 2, 3, 4, and so on and so forth. So this is actually 10. So on the schematic, pin 10, and I was just going to be one of those cases of this should probably be okay the way it is with this 10K, this 33K. My resistor is probably not required. Um, in fact, I probably should take R30 out because we have uh, these. Um, but yeah, I think that in order for this to work properly and not alter the switch configuration, because this thing's going to get turned on and alter the way that these switches function. Um, because we're gonna, effectively jump this into time, which is which is clearly what's happening when the radio is. So if we flip this to time, when the radio is on, we turn this on. Yeah, that's exactly what's happening. This is just being flipped into time mode instead of counter mode. So what I think is going to end up having to happen is TR403 or R434 are going to have to get pulled out. The leakage on this I don't think should be much of a concern. You could always pull uh, some component here is going to have to be removed. I will alter my drawing here to remove R30 because I think that I'll leave it there actually. The reason being is because I can put I'll just change the component to a polyfuse and move on with life. So if there was for any reason something to happen to these components, we don't damage the microcontroller. Because if this is a polyfuse, we're going to sync whatever it is, draw a bunch of current through here, trip the polyfuse, move on, sort of thing. So I'll change that accordingly. So yeah, and that's a big part of how trying to interface new logic with old logic is sometimes you don't exactly, it doesn't become very apparent to you what they're doing. And that became literally as I was doing this became apparent as what's going on here. It's just that I keep thinking of this as these are the same and they're not. And, okay, it's a ground, it's a negative rail, and I keep thinking of them the same, but they are only the same in one state. So, and that's when the radio is on. When it's off, this is still 0 volts, and this is going to be 13 and a half-ish volts. So, hence turning this on, which turns this on, which flips this into time. So, there you have it. That's how it detects whether or not the radio is on. And that's exactly what I was effectively going to do with that pin. So, there you have it. Anyway, and for those who are interested, this is actually my first time with KiCad. I have not used KiCad before. This is my first go at it. I think I've made a few mistakes here and there. There's a board layout. You look at the board layout, you'll know that those who've worked on a Cobra 2000, they know what the board layout they know what the board looks like. There it is. They know what it is. But for those who don't, it's inside of a cage, okay, that you really can't see here. You see the 4 mounting holes. Inside of a cage, you've got voltage regulators over here. This is your 5 and your 8 volt regulators. This is the SCR that we saw before. This is the power connector. This is the frequency reference frequencies in the 7.8 and the 35-ish megahertz come in right here. And this is the one that goes to the radio and all the switches. This goes to the display. So this is omitted. My display connector is right here. And you can see the power on detect here, and this is the pad for the resistor, and it goes up to the microcontroller, and this is the diode here. Can't really see the footprints. You can in 3D mode. So here's the 3D mode. It's quite nifty. We don't have all the footprints. We don't have the diode packages, for example, the SOT 323s, and we don't have these Molex connectors. One of these is the like some of the annotations. I got to work on the silk screen. I've started working on it, like placing the resistor, the designators for the resistors and these various components. But I have to get to these connectors now. I've already done some of them, and I have to do the rest. But yeah, it doesn't have the 3D model for this. This linear regulator or TO220 package is actually not what's going to go here. But you know, there's no real. There was a footprint for it with no silk screen, which is what I wanted because the part that's going to go here is actually a switching module. And I put this in the same spot as the original SCR. The reason being is because I figured, well, if things work out, maybe you can use a linear regulator. Linear regulator is cheaper than a switching module, but I can't see it being the case. This circuit draws about 50 milliamps. Okay, now that doesn't sound like a lot because it's not. 50 milliamps is not much. The display draws 200 milliamps when all 4 lines are active. That's the problem. So you have 200 milliamps have to be delivered, and I need a 3.3 volt power supply for it. So this supply has to deliver about safe margins 300 milliamps. So it needs to be switching supply because we're going to give it 14 volts, so on and so forth. So yeah, and so anyways, the 3D model is kind of cool. There's my some more bypassing on the back. I still have to do some little bit of work on the layout and add little components, a little bit more bypassing is here and there, bypass gaps, you know, filters and stuff like that. But I had to figure out in KiCad how to do via stitching. It was not readily obvious. It doesn't really apparently support via stitching, so you have to do some little trickery. You have to actually make a component to put down that's a via, and as it hits midnight, things start updating on this computer. So yeah, other than being late, this is pretty much what I worked on today. And I kind of like uh, the 3D thing going on here. Another thing that people probably point out is why I put these vias and these pads. Well, it's actually a habit I have doing that. It's a space saving thing. I've got vias under pads I do it all the time. Save space because think about it. If I put the vias for this, uh, you know, in front of it, then I got to go from there to the via and then to the component leg. So I just a lot of times just stuff the via in the pad, and that works just fine. Soldering, yeah, it can be a little interesting because it does wick heat through the to the other side, but the other side it's not connected to anything. So if you look over there, you see the vias. You know, it's going to go to that track, but that track is, you know, it's a fairly thin track. It's just not going to wick up enough heat to make much of a difference. Um, I like how there seems to be some sort of depth, like you can actually see the copper thickness on this rendering. It's kind of neat. Um, I never really played around with the 3D modeling. I mean, Eagle had it, you know, Altium, all the other, you know, commercial package stuff that I've used have the 3D model, but I never really played with it. Um, I've been looking at it on this one because this is a free package. KiCad is free, and I was able to figure it out, you know, within I don't know an hour. I was pretty comfortable with it, so um, I wouldn't let anybody who's used a commercial package like me be afraid of KiCad. This just seems to work just fine. You know, little quirks and things like that. I had it crash once, but I think it's because I was doing something that it didn't really like me doing, which was monkeying around with the component footprints. And it got rather upset, and I wasn't able to reproduce it, so it was just a one-off thing. Absolutely no telling. Um, anyway, you notice that half the board's not used. Well, by area, more than half the board, because this is really not a whole lot to it. I mean, we have this module, which is, you know, CMOS and TTL, and this, which is a microcontroller, and a lot of just, you know, interface, you know, logic pull-ups, things like that, because that's what this stuff all really is just pull-ups. Um, you know, and various, you know, methods of interfacing with the analog circuitry in the radio. So, yeah, there's really not a whole lot to this. It looks harder than it is. It sounds harder than it is. The magic in this is actually in software, more so than it is in hardware. Um, Talking to this beastie over here, um, which is uh, the synthesizer, this turned out to be a complete pain in the ass to do. Um, the code for this is, yeah, it's a pain in the ass. Take my word for it. It took me a long time of reading the datasheet to figure this damn thing out. You know, how to get it to you know, how to get it to output RF. Um, you know, it was a pain in the ass. So anyway, that's pretty much it. I don't think I really have very much else going on. Um, I'm probably going to build or do the display board next, um, and work on the code a little bit. I have to implement. The last thing I have not implemented is this power on off. Um, so I have to implement that in the software, and then test it, because I'm not entirely sure um, about this. I need to change that to a polyfuse, um, and I'm not entirely sure. I need to actually breadboard this. I've got the prototype. I need to actually um, wire up a harness to plug this thing into the radio and see what works, what doesn't work, because um, this stuff right here, if I can get back to it, um, yeah, this thing right here is gonna cause me trouble. Um, so I need to figure out what to do with this. The one I had thought about before is um, jump R35, 435, so that the 10K is in place, and this is all I really needed. Um, but it looks like this could stay, but uh, TR403 is going to have to be cut out, or preferably TR404 is going to have to be cut out. Um, so I think that that's what's going to end up being required here. TR404 is going to have to go away. It's going to muck up these switches that I'm using for other things. Pin 3 and pin 4 um, go where? I have to remind myself. I think that I got those labeled as option. Um, no, those are the beeps. Those are the beeps. So, yeah, because that's what that is. That's the three switches that if you push one, it pops the other two out. They're ganged. So, or is it these? I can't recall which ones it is. There's a set of three switches that are ganged and a set of three switches that are not. To go to the front of the radio, these are ganged and these are not. These are, you push them in. You can set them um, accordingly. Um, and these, of course, are implemented as well. But you know, that's what we have on the display. You have hours and minutes in the set. I have a reset line, and of course the clock and data, and the power to the display. So yeah, I mean that's basically it. Um, more radio interface logic. You see, we got transistors, we got zeners, we got resistors, and DC blocking caps, things like that. So yeah, not a whole lot really going on. Just need to change this, add a little bit more filtering to this, and move on with life. So I hope this was interesting, and I hope this served as a good update for those who've been asking me, what's going on? Have I stopped mucking around with it? The answer to that is no. Oh, and before I forget, um, the switching module. I've started using these things in various other projects, both personal and for work-related items, um, and that's these. Okay, let's just get to DigiKey and pull this up. These things right here, these Recom or Murata DC-DC converters. You look at the price. Okay, that's obviously a lot higher than you can buy a linear regulator. But this is not going to run, okay, with a linear regulator. The voltage, 3.3 volts from 13 and a half, 14 volts is a stretch. Sure, you could do it, but you're wasting a lot of power and making a lot of unnecessary heat. Hence the original module here. This thing got incredibly warm. Um, and rightfully so. I mean, first of all of this old, 74 series logic and old CMOS, this stuff took a lot of power, so the module ran warm anyway. Um, these regulators, um, these linear regulator circuits, um, they take the 13 volts and drop it down to 9, and so on and so forth. Um, these things are they make a fair bit of heat. We got this 12 and a half volts that goes to 5, and we got all the decoupling going on here. They've just got it all tied. That's perfectly okay. Um, but we make a whole bunch of heat. I find this to be rather interesting too, and this is why you get around 13 volts here instead of 13.8, because we just lost zero point 0.6, zero point 0.7 volts right here in this diode. It's a rather interesting way to do that, because I think they're using the diode voltage drop to their advantage. But um, other than that, I really can't see the purpose of this diode actually being here. It's just rather curious. Um, but I think they're just using that. They're taking advantage of the voltage drop just to dissipate less heat in these transistors. Um, so they're just sort of, taking a little bit of the edge off, which is okay. But anyway, I mean, this is basically it. Not a whole lot else going on. I see some boo-boos here. I think that and this is another thing. Actually, no, okay, these are here. I didn't see these before. Because I had to alter the pad, the footprint of this a little bit. When I import the netlist, this tends to get broken, and it goes all wonky. What I end up with is these don't these pads don't are no longer connected to the nets. So anyway, that's basically it. Um, my last thought for this is I have basically everything else implemented here. Let's see, we've got somewhere in here microphone, transmit, radio, the beep noise. This is the noise out, and the squelch. Squelch is for the scanning. Um, these have been left open deliberately, 30, 31, 32, and 33, because this is like not SS, MISO, MOSI, I think. This is the one of the SPI buses on the microcontroller. These are left open on purpose. I'll probably, if I think about it, I'll take these out and put them like down here or something in a pin header, and along with the I squared C. I'll put it down here at pin header, and then I'll put power on the other side. Um, and the reason for that, and maybe a connector in here that goes from another pin header. The reason that I have for that, or the thought is, if add-ons. Case in point, some people like idiot lights. Um, and there are the drivers to do that for PWM. I don't want a PWM out of the microcontroller. I can. It works just fine. I don't want to do it. To drive lights, get a damn LED controller and throw it on here and throw a connector. I'm gonna have 12 volts here. Um, so I have plenty of room in the module to put a pin header, to do some board-to-board connectors here. And if you want to later on, if I engineer it, and I got the pads there, it'd just be a matter of plug the board in, um, and then out of this connector would be whatever you choose, like lights. Okay, the connector will have lights or power, LEDs outputs, so that you could put up your idiot lights. Maybe if I implemented a clock, um, you know, I still probably will attach this pin, which is pin 1 here, to something. I might put the pads down here for an SCR because I might implement it, and maybe the module could be, because it's attached to the SPI I2C buses. It could be a real-time clock module here, which wouldn't output anything, but it would turn the radio on and off, alter the behavior. So there's a lot of possibilities with the room that is right here in this area. It's just you could do all kinds of stuff here. So that's kind of the thought, which is why I left um, this SPI bus on these 4 pins alone, and clock and data are just right here for I squared C. It's just a matter of there's 2 vias right under there. It's just a matter of pull those lines down and move on. Anyway, guys, that's basically it. I hope this was interesting. Um, hope you guys like it. Let me know. Add any, inquiries, questions, comments, whatever. I'm always around, so ask away. So till next time.